is the polysaccharide slide. And basically, again, this is when you have these sugar monomers that come together and they form these biopolymers. And so we'll talk about some of these natural biopolymers, what makes them unique, and then what properties they have. And then from that, we'll transition into the chemistry of taste, where we do some taste testing with these sweeteners. Cellulose, you've probably heard of, is a polysaccharide. So again, poly means many. And so again, these are biopolymers. And this one is a polymer of D-glucose monomers. This nomenclature here, again, beta is the chemistry of the anomeric center where the oxygen is up. The thing in the parentheses 1 to 4, that's telling you the linkage from one monomer to the next. So where you have that beta anomer, that's carbon 1, and then it's linked to carbon 4 of the next, that should be a 4. Carbon 4 of the next glucose. So overall, that's an ether linkage. And that's how, if you notice in the square brackets, that N, that's the repeating unit of cellulose. And so natural materials, including cotton, wood, and hemp, are largely composed of cellulose. So if you've ever held like a ball of cotton, you know that it's really what it is just a string of cellulose. I mean, you can pull it apart. That's what the machine does when it's harvesting it. It's pulling it, the boll, the cotton boll or whatever, away from the husk. And then cotton, obviously, since it's a natural material, if you look at the composition of your shirt, I'm an Under Armour fan. This is a synthetic material, so there's very little cotton in it. I mean, cotton's not terribly stretchy. You can stretch it a little bit. But cotton, you can add dyes to it and dye it pretty much any color. The thing that I personally don't like about cotton clothing, it doesn't breathe well. So if you run hot body temperature wise, like you're going to retain heat in cotton, whereas these synthetic ones, help you dissipate heat a little bit. Natural materials are made of cellulose. Chitin is an organic polymer where basically the 2 position, so if you look at the repeating unit, the 2 position of glucose has been substituted for an amide. So that OH at 2 has been substituted for an amine, which has been acylated. So overall, that's an amide. So these are called deoxy sugars. Once you remove an OH group from the ring, it's deoxy, and then whatever functional group has replaced it. But it's still a glucose derivative, as you'll note. The substituents are equatorial, and you can see the name here. Carbohydrate names get pretty long. But some of the things, the beta, again, that's the anomeric linkage. The D is the natural sugar. N means nitrogen. Acetyl is that 2-carbon unit of the amide. Gluco means glucose. You'll see this nomenclature, paranosyl, that means 6-membered ring. And then the 1 to 4 linkage. So that name tells you about the repeating unit in the polymer of chitin. And so it's the second most abundant polysaccharide on Earth. And if you're interested in biology, it's cell walls and fungi and exoskeletons and crustaceans and insects. So if you're stepping on like a cockroach or something and you hear that crunch, you're breaking their exoskeleton, which is made of chitin. Starch is shown here, and now it's still D-glucose, but notice that anomeric carbon is now alpha. So just by switching from beta to alpha, we've made a new polymer. And so there's the repeating unit with the 1 to 4 linkage. And so this is amylose or starch. And it has these different forms, linear, so just like a straight line, or it can start forming these helices. And so that's basically where instead of a line, it starts spiraling. And those different forms have different properties. But if you're like me and you buy your Barilla or Great Value spaghetti at Walmart, and you have your boiling water, you put your spaghetti in there, it gets cloudy, right? That cloudiness is due to the starch sort of coming out of that spaghetti. Even though it's got a lot of OH groups, it's sort of not terribly soluble in water, I guess, because you see it coming out as that white solid. So there are many more important disaccharides, but what I really want to just spend some time talking about and doing the taste test is on sweetness. And so taste is a perception of sweet, sour, salty, bitter, and umami, and that's savoriness. So that's umami is sort of like when you eat steak, that sort of flavor you get. And so sweetness is a perception. So we all are humans and we perceive things differently. So the science of taste resides on taste buds on your tongue. And so the taste receptor type 1 member 2 is actually a protein that's encoded by this gene. And so when you get into like biochemistry, you'll talk about enzymes and what they're made of. They're a different sort of biopolymer made of amino acids. But this is what happens when you taste something. So the molecule binds to the receptor, and that changes, triggers a conformational change in the receptor. A G protein is activated. Phospholipase C is then activated. Inositol triphosphate is generated. The receptor is opened. Calcium is released from the endoplasmic reticulum. Maybe that makes sense to some of you that studied biology. TRPM5 channel is activated. There's cellular depolarization, so that's the movement of ions. CALHM1 is activated. So again, these are all different enzymes. ATP is released. A neurotransmitter activates neurons, and the taste bud is innervated. So all of that happens sort of almost immediately as something hits your tongue, right? I mean, as soon as it's in your mouth, you're perceiving something. And so with perception, there's emotions. And as my kids say, are you mad or happy or sad? So obviously we all gravitate towards eating things that taste good to us. And, one thing like cilantro, how many people like cilantro, like on your tacos and stuff? How many people don't like it? So does it taste like something to you?
It tastes like soap.
It tastes like soap. So that's a common thing with cilantro. And again, that has to do with like your biochemistry, like the genes in your body give you that perception that it tastes like soap. Yeah, cilantro is a fine line. You can definitely overdo it, right? So it's interesting, and that gets into, things like epigenetics, where environmental factors affect genetics, and that's you'll learn more about that in biochemistry if you proceed that route. Some disaccharides that are common in our diet. So again, a disaccharide is the linkage of two monosaccharides through the anomeric carbon. And so that linkage, that's the glycosidic linkage. So this is glucose, that's why it's called glucosidic linkage. And then the other sugar that it's bonded to, that's fructose. And so sucrose, which is table sugar, which is in this bag, I promise you this is table sugar. So sucrose is just your normal sugar, that you cook with. It's added to stuff. So over the arrow here, you see this alpha glucosidase or beta sucrase. In biochemistry, things that end in ASE are enzymes. And an enzyme is just a large biomolecule in your body that carries out a very specific chemical reaction. And so you can kind of get an idea based on the name of the enzyme what it does. So these enzymes basically hydrolyze those specific linkages. And so of that disaccharide, you form the alpha D glucose, or you form the fructofuranose. So again, the pyranose is 6-membered. The furanose is 5-membered rings. And the furanose is derived from glucose, but some other things have happened to get it in that form, that 5-membered ring form. So one note here, if you look at the anomeric carbons in both, so I'll circle those or dot those in blue. So they're connected through this ether linkage, meaning they don't have an OH group. And if the anomeric carbon does have an OH group, it's called a reducing sugar. So since they do not, they're not reducing sugars. And there's an old-timey reaction called the Tollens mirror test for reducing sugars, where you take basically silver, the sugar, you mix it up. If it does reduces, it plates the silver on the glass, and that's how like Christmas ornaments used to be made. If you see no reaction, then it has some other linkage other than OH. So how is the fructose formed? So again, there's D-glucose in the Fisher projection. We have OH, right, left, right, right. And what can happen under physiological conditions is if you look at carbons 1 and 2, what's basically happening is the hydrogen on carbon 2 is tautomerizing. So the H that I'm circling on carbon 2 in glucose ends up on the OH in the ene diol. and that just basically means there's an alkene. And then the diol just means from carbons 1 and 2, they're alcohols. And so this will undergo a further tautomerization. In which you now form a ketone at carbon 2. So that the aldehyde tautomerizes to that ketone. And so that is a ketose. So remember, if it's an aldehyde, it's an aldose. Now it's a ketose. And when this thing can cyclize again from that carbon 5 OH, it will form a ring up into that ketone to give you the 5-membered ring. So in like a lot of sodas or pops or soft drinks, you might see it under the ingredient list, like HFCS. That stands for high fructose corn syrup. So it's isolated from corn, and then the U.S. government, it's a commodity that's subsidized, so we have all this stuff, we need to use it, so it's put into the diet. So the North American diet has a lot of added sugar to stuff that you really don't need to survive, right? And so that causes a lot of health issues if you have too much sugar. It's like if you were filling your gas tank in your car, pardon all the electric car drivers in the crowd, but if you're filling your gas tank, the nozzle shuts off when the tank is full, right? If you kept going, it would overfill and then be wasted. So your body is sort of like that. You have a minimum dietary requirement, but if you're like me, it's like you can't stop eating Doritos, so it's like you've eaten like 3/4 of the bag, and that's way more than you need. So there's some biochemical stuff that's gone haywire, right? Your stomach is sending a signal to your brain, stop, but you don't want to stop because you're watching football and it's like, I want to just keep eating. So it's our behaviors are a little bit harder to control. But the excess sugar leads to things like diabetes and metabolic syndrome. It's like once you have diabetes, then there's poor circulation, and then people get these issues with their extremities, blood circulation to fingers and toes, and you get wounds that don't heal, and so that's why it's called a syndrome, because it's much more than just blood sugar at that point. So another disaccharide is lactose, and so now the difference here is you have the C4 epimer of glucose, that's called galactose, bonded through a 1,4 linkage to glucose. So now we have two different saccharides making up that disaccharide. So lactose is a milk sugar, and it's metabolized by galactosidase. And so to note at the bottom, as we're building up here, lactose is perceived as 0.3 times as sweet as sucrose. And so again, the thing to keep in mind as you're looking at these is how the alpha-beta configuration, the individual saccharides and what positions they're bonded to, impact the material and its sweetness. Maltose is a digestion product of starch. So the amylose gets digested, it forms maltose. It's found in malts. So example like malt liquor. Notice now it's, again, it's just a disaccharide of two glucose units, again with that linkage now being alpha at the anomeric carbon. And so maltose is less sweet than sucrose, about 0.4. Again, I don't know the exact scale of how these things are measured, but someone's done this type of study. So again, having too much sugar in your diet is a bad thing. So what have people, corporations done? Develop artificial sweeteners that are non-caloric, meaning it's a chemical that will give you the perception of sweetness, but it's not metabolized in the same way that sugar is. So as I said, this corn syrup is added to a lot of things to increase sweetness, and sweetness is sort of addictive, right? I mean, once you start, you can't stop. But the excess, again, leads to these issues where your body just can't process the excess that's in there. So artificial sweeteners are alternative additives that don't undergo the normal metabolic processes. So it gives you the perception of sweetness, and then it just sort of goes through you, and you don't have any of the negative side effects. Some of these sweeteners do look like sucrose. For example, this one here, which is Splenda, it's called sucralose. And what has been done is at certain positions, OH groups have been substituted for chlorine. So we see there's 1, 2, 3 chlorines. And that's perceived now 600 times sweeter than sucrose. So that poses the question about the perception of taste. When you put that on your tongue, it's a chemical that is eliciting some response, and that's just basically saying like your tongue can sense chemicals. And so again, chemicals bad. Obviously, there's a natural evolution for that stuff, right? Like, if you put something in your mouth and it tastes bad, hopefully you'd warn your neighbors, like, okay, don't eat that berry. Or if you don't like your neighbors, say, hey, these are the best berries in the world. So here are some of them that you'll taste today. Some of these other ones are a little sort of niche and probably don't want to taste them. But so saccharin, which is sweet and low, is about 200 times as sweet as sucrose. And so notice that looks nothing like a normal saccharide. Sweet 1, which is acylfam K, it kind of has some things that look like saccharin. This group, we saw this sulfur with 2 oxygens and a nitrogen, that's a sulfonamide. So that sort of has that as well. Here's sucralose. Again, that's looking more like a derivative of a naturally occurring sugar. Aspartame, which is equal or NutraSweet, about 200 times. And this one is actually a peptide. So there's a carboxylic acid. Here is an amide, and then there's an amine. So this is called an amino acid. That linkage there is called a peptide bond. So this, we would say since there's 2 amino acids, we would say that's a dipeptide. And so what's interesting to think is these different classes of molecules peptides, carbohydrates can still elicit sort of the sweetness perception. Now, if you look at neotame, this one is 10,000 times sweet as sucrose. And really, if you focus on that amine group here, what they've done is just add this like aliphatic or saturated side chain. And so that probably increases the sort of solubility of that molecule as it, enters those receptors. And then this one is 20,000 times advantame, and they've just changed out, that tert butyl group now for an aromatic group. And so to take away from that is these functional groups can drastically change the properties of these molecules. And so those are synthetic sweeteners, some natural artificial sweeteners. These are things isolated from plants that are just added because they're perceived as sweet. And the Food and Drug Administration allows these to be added because they're called generally regarded as safe. And that really comes from studying, indigenous peoples that have eaten plants for thousands of years and have not developed any sort of cancers or chronic diseases. So it's like, okay, that additive from the plant we can put in because you don't just keel over and die from it. So one of the ones that you'll taste today, I think it's this, it's stevia. That's perceived as 400 times as sweet. And so if you look, that sort of polycyclic molecule is the scaffold in which these glucose residues reside. So from those alcohols, you're just bonding to different positions of glucose, and presumably when that gets metabolized, it frees up the glucose, and that's sort of what you're tasting, but you'll find out. Some other artificial sweeteners, and these are like, look at these numbers, these are huge. The common thing in these, this central carbon with 3 nitrogens, that's called a guanidine functional group. And basically the guanidine is common in each, and then what's changing is the stuff bonded to the nitrogens. And so these are really getting, crazy amount of sweet. It's like, I've never tasted one of these. I can't even imagine what that level of sweetness would be like if it, like some wormhole in physics where your brain just can't comprehend it. But 230,000 times is sweet. I mean, that's up there. So what we'll do for the remainder of the class, and let's try to be as clean and neat as possible. When you tear these open, I do not recommend dumping it in your mouth. Maybe just dip your pinky in, or your coke nail, as whatever you have. Just put a little dab on your tongue just to get a taste. So we'll go through all of these. I'll give you a couple minutes to formulate some thoughts, and so that's what we'll do. Oh, I forgot to mention, so this is 65 grams of table sugar. So if you go to like the Coke vending machine and you get a 20-ounce bottle, that's how much sugar is in one Coke. So I converted to sugar-free drinks a couple years ago just because I got to a point where it's like I always felt bloated after drinking like just any sort of normal amount of sugar. And, I took that as a sign of my body saying, okay, we're tapping out here, it's too much. But that's just in one. So if you drink multiple ones per day, you're getting a lot. So we'll start with the natural ones. So if you want to get sugar in the raw, So what is the Shake Shack in front of campus over by Qdoba? What's that called again? I never remember the name. Huh? Smoothie King. So Smoothie King, they say we don't have sugar. They call it turbinado. And so it's still sugar. But look at this word. It's called cane sugar. And so sugar cane is where a lot of sugar comes from. And if you open it up, does it have a color? So it's not like this white. So like this stuff comes from that and through like bleaching, not like sodium hypochlorite bleach, but sugar is bleached to get it to this. And so that has more of like the natural other stuff in it. And so that's probably what you're tasting when you taste turbinado. But when they're selling it to you as like less sugar, it's not as refined. And so what do you think it tastes like? Is it pleasant or not pleasant? It's not bad. So again, our I should probably mute the recording, but I'll say this anyway. Our country is founded basically on slavery, right? So sugar plantations, back in the 16, 17, 1800s, that was a big source of income, right? And if you read about, the sugar plantations like in Louisiana, like just the brutal conditions, and what's it? Like the Domino. I think if you drive into New Orleans, you can still see like a Domino sugar building in the distance. Just what goes into taking like sugar cane and refining it into this stuff. I mean, the conditions are pretty brutal. So that's an intersection of like a raw natural material with economy, and now it's a commodity, right? I mean, you can go to Walmart and buy a bag of this for like $3. But if you think of all the work that goes into it, I mean, now it's mechanized in a sense, but historically it wasn't really that way. So the next one is the Domino sugar, and if you look at this advertising, it says premium pure cane. And so, look at the color of it. How does it sort of taste different? So again, this one's been refined. Think of like honey as well. Honey is another vehicle in which sugar is delivered, but it's made obviously in a different way. I guess the other form is sugar beets. Like beets have a lot of sugar in them that's extracted out. And now give the stevia a go. See where your perceptions take you. A little bit of gagging going on. Bitter. Yeah, so the bitterness, again, probably comes from that, that polycyclic molecule, that fragment in the middle there.
No, I didn't put the whole thing. It's just like down in packets and
So, again, you're tasting like that substance. People add this stuff to liquid, make a solution, so that probably changes the perception a little bit.
My mom puts it in her coffee. you don't know how to accurately use a salt bag, you need to
So,
have it at the top.
so those are the natural sweeteners.
Take the salt packet, just dump it on that food.
And so, why don't you try the pink one? This is saccharin. So this is definitely synthetic.
No.
Better than the stevia.
Much better than the stevia, but
Still some grimacing going on.
maybe my receptors are
So it's interesting. I've done this for like 3 years now, and it seems like with all the synthetic ones, students don't like it. But if you go to like Cracker Barrel or wherever, they always have this stuff sitting out, right? So it's like maybe you hit like an age where it's like, okay, now I need this stuff. Whereas like when you're young, it's like you don't.
Yeah, like children have better bitter receptors because it made them less likely to eat poison. I don't know if you know toddlers are apt to just put anything in their
Yeah.
mouth. So the enhanced bitterness sensors are to keep them dying.
And then at some point it probably just gets shut off, and you're like, I'll just eat whatever.
Just eat whatever. It's horrible.
So here's Equal. So this is acylfam K. This is the blue one.
So why do some of these fizz up when you
Like if the drink if it's carbonated, maybe that's just causing the CO2 to be released. I'm not
I
sure.
live in unsweet tea like every day because my parents are diabetics. That's all we have is stevia, and
Yeah.
it like makes foam.
I'm not sure.
I like that one. That's unsweet tea. That's the only one I've tried. This one's just good. That's like whenever you ask for a unsweet tea.
It's better than
That
that.
tastes like, you know the, what's
Oh, it does taste
like,
like
it tastes like fondue.
I'm just thinking
I can't move up the fondue.
And then finally the yellow one's Splenda. So Splenda is pretty common in cafes and restaurants.
old people like
Old people like Splenda.
like seed on it.
Alright, why are we throwing shots at old people? I'm all for all these old people because they're straight. I'm all for throwing shots at old people.
If you sweeten them all, you're a psychopath.
Tastes like the cardboard.
It tastes like
Yeah.
I either drink it either or. If it's unsweet, then I'm drinking unsweet. I'm not putting sugar. Because
So,
That tastes like the fondue.
flavoring water.
of the natural ones, which ones did you like the best? Sugar in the raw.
I really like that one.
Like I hate
Well, I'm not like a big fan of sugary things in
Well,
general.
the Kool-Aid's
So it's interesting, like I said, that
the Kool-Aid's hard.
raw sugar is refined till eventually you get like this. If you look at how like spirits, like alcohol, are made,
Yeah, I have.
they're getting, some fruit with enzymes or whatever, and then they're distilling it, and then they stick it in like casks, right? Most of the color and flavor comes from like the wood. So that alcohol is extracting the stuff out of the wood to give it whatever color and flavor. And so that it's kind of parallels this, right? You're extracting natural stuff out to eventually get to this, but the flavors end up being perceived differently. So what about the artificial ones? Which one was the best? Equal. So again, everyone has their own perception. It's like what we learned about color. You have a general idea what blue is, what red is, but people can perceive those things differently. And taste, I would say, is probably more opinionated. So did you like the natural or artificial ones more? Natural, yeah. Again, chemicals are bad. And so that's going to wrap up today. Again, I said it was going to be pretty short. You have a quiz and you have your exam. There's only a handful of questions on carbohydrates. They're pretty straightforward, so go back to your notes. You'll be able to answer those pretty easily. There's also questions 31 through 35 are bonus questions, so they're 2 points apiece. You got to refer to the end of the exam. There's some data. Basically, you're trying to figure out a structure, and then there's a website that you can link to help you figure out what that is. But each of those questions is 2 points apiece as a bonus. Your interim grades have been posted as of last night, so you should be able to see those in SOAR. Again, as long as you're sort of doing stuff, you're keeping on track for a high grade in this course. Just, again, don't forget to do stuff. You'll be fine. But other than that, any questions before we wrap up? Yeah. The Z-score is basically how you're performing relative to the average. So it's just an equation that your total points is shoved into. Then we look at the average score for everyone, the standard deviation, there's an equation. If the closer your Z-score is to 0, that means that's sort of the average of the class. If you have a positive Z-score, you're performing better than the average. If you have a negative Z-score, you're below the average performance. It has no impact on your letter grade. It's just telling you relative to everyone in here how you're performing.